isoelectric points of protein. In this presentation, we will be going through the definition of isoelectric protein and what
Said,
happens when we alter the pH.
Said it's already done, right? You can go to your slides, slide number 4, I guess. Yeah. Explain
When
from
we
here.
the net charge of the protein molecule is affected by its chemical composition and the pH of the solution. So whenever we increase or decrease the pH of the solution, it gains a charge. At pH lower than the amino acid's pI, the amino acid will have a net positive charge, and above that it has a negative charge. At pH higher than the amino acid's pI, CO, the amino acid will pH that above the pI of the amino protein, NH3 will lose the H plus and CO minus will be as it is. So it has a negative charge. And pH below the pI, H CO minus will gain the H plus and NH3 plus will be as it is. So it has a positive charge. Now coming to next, does isoelectric point affect protein? Yes. Solubility of amino acid decreases at isoelectric point because at this point there is no interaction between the molecules of protein and water, and solubility tends to zero, and it become to it begin like it become like precipitate. It also affects the migration of protein and acidic and basic. Melting point will also be increased at IEP because there won't be interaction with water molecules, but there will be positive and negative charge in the protein, and dipole moment will be maximum at IEP. Now continuing with the next point, how to find the isoelectric point of protein. Let us first see how to find the isoelectric point of an amino acid. We can do that by knowing the pKa values of the amino acid. If a amino acid has only two pKa values, then Pi will be the mean of the two pKa values. Like for example, glycine has two pKa values which are 2.34 and 9.60. So Pi will be 2.34 plus 9.60 whole divided by 2. That will be 5.97. But to determine the pH of amino acid which has more than 2 pKa, we have to use the pKa values which are in the range of the return would present in the solution. Same will be for the protein. Now, coming for the last question, what is the role of isoelectric point in a protein purification? The isoelectric point is significant in protein purification because it represents the pH solubility is typically minimal, and the protein isoelectric point signifies where mobility in electrofocusing system is zero. In turn, where the protein will be collected. Isoelectric focusing, also known as electrofocusing, is a technique used for separating different mixture of proteins by using their pI values.